In this reference video, we will go over circles. And the first thing that we will go over will be the radius, which is a straight line from the center of a circle, the center, to the outer edge of the circle. Could be here, it could be here, it could be here, the outer edge. So this is a radius. The second thing that we will go over is diameter, which is a straight line passing through two outer edges of a circle while passing through the center. So this is your center. It could be here. That could be your diameter. Also, you could start from here and go from here to here. It has to pass two outer edges while passing through the center. Also, two radii end to end makes a diameter. So remember, this is a radius. So two radiuses makes a diameter. Now, the circumference is the distance around a circle, like the perimeter. So that's a circumference, which the formula is pi d, so pi diameter, or 2 pi r. Remember, 2r is equal to the diameter. Area of a circle is the blue part, so the inside piece, which is pi r squared. Pi times radius squared. The arc length, the length of an arc of a circle, which is part of a circumference of the whole circle. If you see this, it's like the measure of the arc. So it's like degrees, not the distance. So this is like 60 degrees. So this is right here is the length of the arc. And so the first thing that you need to calculate is the circumference of the whole circle. So 2 pi r, r is 9, so you get 18 pi. That is the circumference of the whole circle. But what if you just want this arc right here? You just want A to B. And you can do that if you know the degrees. So 60 degrees is this piece right here. The whole circle is 360 degrees. So divided by 360 times 18 pi, which is the whole circumference. And if you multiply it out, you get 3 pi. So from here to here is 3 pi. However, from B all the way a complete circle to back to B is 18 pi, the circumference. Arc sector is a fraction or a sector of a circle. So a fraction of the whole area. So the arc sector is this piece right here, this piece only. Not the distance, but this whole area right here. And so the first thing that you need to do in order to determine the arc sector is determine the whole area, this whole complete area, which you can do by pi r squared. So if the radius is 6, so you get pi times 6 squared, so 36 pi. But if you just want this piece right here, just this piece, the area, so you do 60 degrees divided by 360 for the entire circle times 36 pi, and you get 6 pi. So this piece right here is 6 pi. Now a chord is a line which cuts across a circle, one end to the other end of a circle. Diameter is also a chord. However, a diameter goes through the center. So a chord doesn't necessarily go through the center. And in most cases it won't. So A to B is a chord. You could also say if you had A to B here and it passes through the center, then you call it a diameter. Now this is an important rule regarding chords. From the center to a chord is always perpendicular. It's a perpendicular bisector. So if this is your center and this is your chord and you draw a straight line, this right here will be perpendicular. So you'll have a 90 degree right here. And another important rule is that this piece from here to here is equal to here, because it's a perpendicular bisector. So an example problem could be this. Chord AB, where O to AB, the distance is 5, we want to determine the radius of the entire circle. So I'm saying A to B is 24, and O to AB, O from here to here, is 5. We want to determine the radius. We can do that because we know that this piece right here will be 12, and this piece right here will be 12. Again, this is a rule regarding chords. So we know this piece right here will be 12, this piece is 5, so then we simply can use Pythagorean theorem. 12 squared plus 5 squared is equal to c squared, and then you get 169 is equal to c squared, so c is equal to 13, so the radius is 13. Now, if we know that the radius is 13, and we want to determine this piece right here in red, we can do that, because we know from here to here is 13, right? And we know from here to here is 5, so simply 13 minus 5, we get 8. Now this is just a side note, this figure wasn't drawn to scale. That's why this piece right here is 5, while this piece is 8. because it's not drawn to scale. Another thing that's important is a segment, which is this area right here. And so a segment is the region of a circle that is bounded by a chord, and its intercepted arc. And that's pretty much it regarding circles references.